and welcome to episode 3 of Deep Learning with Pytorch. In this lesson, what we're going to be doing is essentially just looking at tensors, lists, arrays using Python and Pytorch. This is very important. Some of you may know how to do this already, but it starts with the tensor. It's very important to understand the tensors and how they work, and so we're going to start playing around with it, and I'll give you guys some tools that you can use and you can kind of play along. So I'm just going to start going ahead right away and saying 1.0 comma 2.0. Now we have a list right here. We can call up specific elements here. There we have the first one by saying A0. So that calls the 0th element of the list. We could also call the second element of the list, which would be the last one. We could also redefine these. So if we want to change this last element 2, because the way that it always counts can be confusing, but it goes 0, 1, 2. So when we call the 0th element, we get this one. So if we want to change the second element to the digit 2, we can do that. And now when we look at A again, it is now a 2. So we could even make that 2.0 just to make it look better. And it's 2.0. So that's a Python list. The reason that we use Pytorch is mainly because of the data storage and the way it stores these tensors and data is more efficient than in Python. And we can get more into that later, but essentially it's just more efficient, but there's a lot of crossover. So when we import torch, we're just going to be doing the same things here. A equals torch ones, and let's get 3 ones. Now we have a tensor of 3 ones. So everything in Pytorch is going to be in tensor format. There's no lists like this. This is a tensor. And again, if we call certain elements, we can do it the same way. Tensor 1. If we do the 0th element, we'll get a 1. We can redefine them as well, just like we did before. This equals 2. So now when we look at A again, we have a tensor with 2 in the front, 2 on the 0th element. Another important thing that we'll be doing a lot once we get better at this is looking at the shape and the data type of these. So you're always going to be doing this when you're debugging a code. But let's see what A's shape is. Okay, so it's 3. Let's see what its D type is. So this will just tell us what data type it is. It's float 32. And we'll talk about that in the next lesson as well. But it's important to understand that that is a thing. These are specific data types associated with these. But for now, we'll just keep getting used to the format of Pytorch and how to use it. So let's make a tensor of all zeros. And that's what this command does. It'll essentially create one tensor of 6 zeros. So we have that there. Now what if we want to change these to be different numbers? Let's see, we could do this and change it to 1, and then I guess we could just copy and paste it. And just go 1, 2, 3, 4, and 5. Let's go 1, 1, 4, 2, 5, 3, 6. And let's run that. And now we've just updated our points tensor. 1, 4, 2, 5, 3, 6. Now, when we look at this, is this the most efficient way to create a tensor? And the answer is, of course, no. There's definitely going to be a better way to do that. there's always going to be a lot of ways to do everything. So it's sometimes difficult to keep track of and easy to get confused when looking at someone else's code. But that's why it's important to get really good at this stage and just kind of play around with this. So when we do this, we now have the same tensor of 1, 4, 2, 5, 3, 6. It is the same one. I named it points again. We could call this points 1 and run that. Points 1, 1, 1, 1. And here. And now they are the same thing. If you want to look at both of them to compare them, and let's change this to 7 just so it's different. Say we want to look at our two tensors that we just created. So what we have to do that is the print command, because if you think that you can just type points and then points 1, that will not work. We're only going to get points 1. So what we need to do is type print. And this would actually work, but sometimes it's just nice to have everything the same. It will always print the last item that you leave there. So if we wrote points again, it'll print that. But if you write it points 1, it won't. So it only prints the last thing that you have there. So just a important little thing there. It's just kind of the ins and outs of this. You really got to get familiar with it as we move forward with this deep learning lesson. So now let's change points a little bit. We're working with tensors here, but it's all one-dimensional vectors. So let's shake it up a little bit. Let's make a torch tensor, and let's do a 2 by 3. So same numbers and everything. And now when we look at that, that's going to be a 2 by 3 matrix, essentially. Although everything is a tensor, technically speaking. But when you think of two-dimensional, you think of tensor. It goes scalar for 0-dimensional, vector for 1-dimensional, matrix for 2-dimensional, tensor for 3-dimensional, and everything above 3 dimensions would be a tensor. And we can determine what the dimensionality of this is just by typing in shape. 3 by 2. So it is not 3-dimensional. There's only 2 dimensions here. When we did it earlier, like points 1 shape, it should just have one number, meaning that it is 1-dimensional. And it does. It is 6 in that 1 dimension, 6 units. Points is 3 units by 2 units. So if we look at it again, we have 3 rows and 2 columns. Okay, so we can move forward. Let's look at calling the different numbers in here. How do we call each of these numbers? So if we want to get this 1, how would we call that? I think we would say 0, 0. Yes, so that gives us the 1. And 0, 1 would be the 4, hopefully, because we're saying the 0th row, in technically speaking, 0 in the first dimension and 2 in the second dimension. But let's just think about rows and columns for now. The 0th row, the first column. So this would be the 0th column, and this would be the first column. If we look at this, if we do a 2 here, we should get an error because we don't have, that's out of bounds. We don't have a second column here. So let's stick with 1. If we do 1, 1, that should give us the 5, I think. And that's how you essentially call these things. I mean, you could say 2, 1 should give us the 6. Okay, so that's pretty good there. What if we want to call a whole row? I think in that case you just type in the 0 and it'll give you the whole row. Yeah. 1 to get the next row. And 2 to get the next row. Okay. So that's how you call different numbers from any given tensor. Now let's call a list of range 6. And what this range command does is essentially, you can always just check it out for yourself. It just makes a list from 0 to 5. And that's back to the number thing that I said can be confusing at first. We start at 0, so 0, 1, 2, 3, 4, 5. So it is 6 units long, but because we started at 0, we end at a 5 there. And this is called indexing. That's the next point that we're going to get to here. So we can index in a lot of ways here. Let's say we want to go the whole thing. Then you would put this colon here. That gives you the whole thing. Let's say 2 onward. That gives us from 2 to the end. What if we reverse that? This gives us up until the second one. So it gives us the 0 and the 1. And that doesn't include the 2. So if we say 1 to 4, it won't include the 4. It should go from the first, it should be 1, 2, 3. 1, 2, 3. It does include the 1, but it doesn't include the 4. But when it's in the beginning, it does include that. So including the 2 onward. If you go up to the 4, it's not including the 4. So that's important to note. There are other ways, and that's why it's always difficult when you're trying to look at someone else's code, because they might have something like that in there. You know, like a -1, what is that? Well, a -1 just goes up until 1 from the last one. So up until the 5, but not the 5, because we're 1 away from that. Up until the 4, and it includes it in that case. So if you do -2, we'll just get rid of the 4 there. It should be 0, 1, 2, 3, and so on and so forth. It's not that complicated, but it can be at first. Another interesting thing to look at here would say 2, 4, 2. And that might be confusing, but it's actually very simple. We're going to go from 2 to 4, counting by 2. So we only get one number there. Let's go 1 to 4, counting by 2. All right, so in this case, we get 2. So we're going from 1 to 4 in integers of 2. So let's see. Let's make this 20, so we can get a bigger range here. And let's go from 2 to 10, counting by 2, just to give you an idea of the use of it. So 2 to 12, counting by 2. 2 to 20, counting by 2. You can change it to integers of 3. Pretty simple stuff. Okay, next, we could do the same thing if we go back to points. So points is like that. It was the tensor, the 2 by 3 tensor. We can use that same indexing strategy, 1 to the end there, or 2. So this gives us the first row onwards, and this gives us up to the second row, so 1, 4, and 2, 5. So it's the same thing, just applied in a different manner, because this is a 2 by 3 matrix. And I think that about sums it up. That's all it is for indexing. A pretty quick little lesson there, and we'll get into some more complex stuff and some more definitions in the next lesson.